Hi, I'm Dr. Jay Vianney, and my colleague John Teller is behind the camera. And we're here to show you a little bit about the IDS4000 medium voltage analytics and fault detector unit. This is a compact unit that is IP65 rated, hangs out outside on a pole, is integrated sensing and communications. It's a pretty small box. It's about 8.5 wide or so, about 8.5 deep, about the same dimension, and about 5.5 inches high. So compact little thing. As I say, integrated wireless. I'll just put the ruler here to make an honest man out of me here. About 8.5 deep as well. The unit has 4 current inputs, of which 3 are used in the medium voltage case. Has a wireless, has a slot here for a wireless SIM card. It also has integrated wireless comms. Normally there's 2 antennas that are attached here for wireless communications. This thing is just sitting up on the shelf on our bench so that we can show you some of the fault operations going on. There's a console input and Ethernet input, which are normally covered over and sealed when it's operated outdoors on a pole. So this unit is capable of three-phase MV metrology. It does all the conventional things that you'd want for three-phase volts, amps, watts, VARs, and VA at the fundamental. This is a very narrowband device that operates at the fundamental only. It tracks the fundamental frequency actively as it's going along. As I said, it's IP65 integrated comms. In addition to that, for some of the fault operations, it also has a visual indicator built into it. This is a new option that we have. I'll just show you a little demo of that. There are 3 very, very bright, and the camera really you just can't appreciate how bright these things are in the image. 3 different colors for the 3 different phases here. In this case, it's been red, white, and blue. You have your pick, but in general, folks don't see green very well, so we pick things that folks could see. Right now it's flashing a code. We'll describe what that code is later on. This is just a test. So in the nominal operation of this thing, there's a battery inside that's recharged in the normal operation that'll let it indicate for about a week. So after a fault event, if the line goes down, you have enough power in there to run this indicator, visual indicator, for a week. I guess our view is that if you need the indicator for longer than a week, you probably have a lot more deeper problems and bigger problems than this box can help you with. So we think that that's probably more than sufficient for the normal need. What we'd like to talk about a little bit with this unit as well is some of the interface. It turns out that the interface on this, let me just turn that flash off because I'm going to need it later on. The interface on this unit is extremely flexible, and you can interface it to just about any sensor out there. On the current side, the differentiating or not. On the voltage side, just about any scaling that you want. Typically, when it's used in the overhead environment, the sensor we provide with it, and here's an example of, for 15 kV classes, a line post sensor that's made by Piedmont bushings and insulators. This sensor provides you a voltage and current signal that is interfaced directly to the unit, scales directly off the MV. So you get MV voltage to ground, as well as the current in the conductor. Everything is pre-calibrated with the individual sensors. The only thing that you need to tell the sensor is how fat the wire is, so you need to input the wire diameter. There's a lot of nice features about this particular sensor. One I like a lot is there's a very, very nice saddle for the conductor to sit in, so that it's very, very well retained, and it's well retained in position on top of the sensor. Really simple install, and a nice high quality sensor that we've had real good luck with. This one comes in 3 units. It's a 3-unit family for 15, 25, and 35 kV class. This one is the little one for 15 kV. The other ones are considerably larger and considerably heavier to take care of the BIL ratings that are required. But real nice medium voltage sensor that we've already interfaced to the thing. If we just talk a little bit about the high current capabilities, the fault detection capabilities of this thing. The fault is configured on, there's actually 3 segments of the detection that goes on. High current faults are probably the ones that we care about in the US for Y-connected MV systems. And each phase of 3 is provided with 3 magnitude duration set points. So there's 3 on the A phase, 3 on the B phase, and 3 on the C phase for a total of 9. The idea is that these conditions are all independently examined at the sampling interval of the unit, which is at every 250 microseconds. And for every phase, the first one that trips out takes that indication. The whole idea of the three independent is that they can be coordinated with upstream protection. So the whole idea is that this thing sits southbound of upstream protection and can be set up a little bit more quick as necessary to give an indication and get that message out before upstream protection goes in the case of a high current fault. This unit is also capable of doing sensitive earth faults for delta-connected floating systems or even lightly or even hard-grounded delta systems in Europe. It does a real nice job on sensitive earth faults with a noise floor of about a half an amp. Also has built-in an integrated adaptation algorithm that allows you to adjust the sensor gain for unanticipated magnetic interactions on the poles, essentially zeroing out the SEF current a priori. Very, very helpful in environments where there's a lot of stray magnetic field around. Works really, really nice. And in addition to that, there's also an upcoming release in the firmware that will also handle what is called a pure earth fault in the case of the Delta system, which is a fast, somewhat larger fault to ground that's separate and distinct from a phase-to-phase fault. So all that's fine. It's used in Europe and other places where there are Delta configurations, typically in the U.S. Where we're wide connected. It's the high current faults that are of interest. So we thought what we'd show you here is an example of a high current fault. And let me show you what I have, try and explain what's going on, because I think the result will be a little anticlimactic if we don't tell you kind of what it's all about. What I'm creating here is I have a waveform generator down here that's generating three-phase power, and it will generate a transient. And the transient that it's going to generate is precisely this one, where the current on phase A, which is the red indication up there, changes from nominal to 1.3 times nominal for about 5 cycles, and then drops back down for 2, comes back up, or actually 1.5, comes back up to 1.6x nominal, now drops back down for 1.5, and then comes back up to 2x nominal and drops back down. The way this unit is set up right now is the unit's internal trip points and the source are identical. So if I fire the source out with these waveforms in there, it will detect nothing and report nothing. However, the waveform I've got loaded into it just for the purpose of demonstration and also for time is actually just slightly longer. In particular, what I've done here is to stretch the center. Instead of being just 4 cycles, I've actually got the source stretching it to 4.5. And so what will happen will be, if the source, which is a little temperamental, behaves properly, we will trip out on the middle condition, which in this case is the second condition on the A phase. And what we ought to see is we ought to see a red with a 2 flash associated with it, meaning that the fault occurred on the A phase with the second condition applied. That was this 1.6x condition for slightly longer than 4 cycles. So let's go ahead and do that and see if this darn thing works. So if you can show the condition here, John, it's pretty quick.
Let's see if I can get it all.
We'll just fire it off. And the thing fired.
Yep.
And indeed, we got the indication that we anticipated. So it says, hey, look, I saw the condition that you specified on the A phase, and it's your condition too that's flashing. That'll go on for a week. Hopefully you'll figure out the problem before then, and it can be reset either manually or reset on voltage recovery or whatever you'd like. That's all user configurable. That's about all we wanted to say. Very flexible unit, lots of capability, integrated standalone IP65 hanging on a pole, visual indication. I think a nice compact addition for improvements and reliability work on the medium voltage. That's it from here. Thanks a lot.